Good morning, everyone. Welcome to the session. Okay, so streaming has started. I have also gave you the links. All right. So how was quiz one? Or can you guys guess which question you are seeing on the screen? Am I audible?
Yes,
Yeah. Okay. Maybe I will create a poll. You can answer in the poll. Okay. Uh, uh, did you guys feel? I think answer key is out, right? For quiz one. If you guys feel if any of the answers is incorrect or any ambiguity in the questions, you can always uh, get back to us. And is there any question that is completely out of syllabus? And okay, so I have created a poll which asks just for the quiz one level. So is it easy, medium, hard? Uh, I can see 7 people here. At least 7 votes I can expect, right? Can you all vote? Open the polls within the Gmeet itself. You just have to click an option. Okay, so you all can vote in the polls, and by then we'll quickly uh, quickly go through the quiz. Okay. The first one is easy, no? Whatever the question that you guys are seeing, whether this x of t is even, odd, or neither. Maybe. As you can see on the screen, the answer is neither, right? So you can see there is a height difference between these two peaks. So even if you flip with respect to x-axis and then y-axis also, you will not get back the same curve. Therefore, it's neither even nor odd. What about the second one? Anybody? What about this question? Okay, how many of you did this question? Just raise your hands. You don't have to unmute and talk. Okay, no one. All right. Should I discuss this or you guys will try it out? Okay. Priya says option A. Okay. So the hint for this is you just have to write this cos square theta as 1 plus cos 2 theta by 2. Right. So write it in that way, and also sine square theta also we can write it as 1 minus cos 2 theta divided by 2. Right. So using these two identities, trigonometric identities, you can simplify this, and then once you know if we have to write it in the phasor form. Right, so we just have to bring in I sine j sine thetas into the picture and then do some manipulations and you'll get it. All right, so that we can do. This is fairly straightforward now if you know Dirac delta properties. I have emphasized this in revision session also. So it is clear that option B is incorrect. Right, it should be f of c. Right, it should not be 1, it should be f of c. Therefore, that is not correct. This also we have done already. Right, so some signal given to us, splitting them into sum of unit step signals. Right, so answer will turn out to be option D. Right, u of t plus u of t minus 1. Then you have to subtract u of t minus 2. Then you have to subtract u of t minus 3. So you'll get this nice picture. What
Sir,
about, yes,
the above question, if we see the amplitude is raised to 2, right?
correct.
So why didn't we just like amplified the UT graph with 2?
Okay.
Like why didn't the answer couldn't be C?
So why is it not C? Because you know u of t, right? U of t will be
Yes.
like this, no?
Yes.
U of t already has amplitude of 1,
Okay.
right? And then from 1 to 2, you want the amplitude to be 2,
2. Yes.
right? So I have to add u of t minus 1, which will give me one more unit, right?
Hmm.
And if I take these two curves alone, these two signals alone, then the plot would have been like this.
How, sir?
Okay. So what is u of t minus 1? How
It
does
will
u of t?
be, yeah, on the, yeah, this. So how will this add to 2, right? I'm not getting this.
Huh. So you have one signal u of t like this,
Hmm.
right? And you have another signal u of t minus 1 like this, correct?
Yes.
So now if I'm adding these two signals, so I'm adding these two signals, right?
So even the y coordinate will get added. Like, okay.
When you add two signals, that is how it will be, right? The amplitude values will get added to each other, no?
Okay, I messed up here.
Yeah, yeah. You see this is 0 and this is 0 till t is equals to 0. So sum of these two will be 0.
Yes, yes.
So till here it will be 0. But then between 0 to 1, this blue curve is 0. This is 0. But this is 1. Right? So 0 plus 1 will give you 1.
Okay.
Correct? So this will become 1. And
I took
then,
it as subtracting, like I mistook it.
yeah, yeah,
Maybe subtracting. I don't know.
yeah, you should add, no? So at 1, both of them become 1.
One, so two. Yes,
It
right.
will become 2. Right? But
Yes.
it will stay 2 throughout till infinity.
Yes.
Right? But in our graph, the amplitude got reduced to 1 after 2. Right?
Yes. Yes, sir.
So then I have to subtract something, right? And I have to subtract only 1 unit, not 2 units. Correct?
Yes, sir.
So then if I subtract u of t minus 2, then from 2, I'm subtracting 1 unit, then it will just become 1. And then again, if I subtract u of t minus 3, that will become 0.
Yes, got it.
Okay. Yeah. So this is okay. What about this? I think this is the only question that is slightly trickier, not difficult from my perspective. I'm not sure what you guys have. Okay. So we have given a signal that is 0 till t less than 0, till t is equals to 0, right? So this is x of t is 0 for t less than 0. So that means this is 0. The left side is just 0, right? And then on the right hand side, x of t toggles between 1 and 0 in every 1 second. So in every 1 second, at one time it will be x of t will be 1, and 1 unit 1 second it will be 0. So 1 0 1 0 1 0, and it goes so on. So there is a 3 dots, and it says that it goes till infinite, right? So what we asked is, we asked the energy and power of this signal, right? Okay, now can I see some hand raises? How many of you did this? Good. One. Anybody else? Okay, two. Okay, firstly you should identify what kind of signal is this, right? So is it energy signal or power signal, right? So it will be a power signal, because it is very evident that you can see some area under this curve, and this area will repeat till infinite. So even if it has some small area, if you add these areas together, it will go to infinite. So the energy will be infinite. If energy is infinite, turns out to be power signal, right? So how do I compute power? Power, when you compute power, this is, observe, this is not a periodic signal, right? You can't just simply compute period in this interval, sorry, energy in this interval, average energy in this interval, and say that is the energy for, that is the power for the signal, right? So this cannot be done. And the reason is, this is not a periodic signal, right? So how should I compute? Using the formula that I know, right? So power is limit t tends to infinite, 1 by t integral minus t by 2 to t by 2 x of t dt, right? So now we can see that limit t tends to infinite, 1 by t. So if my somewhere t by 2, and this is minus t by 2, all I have to do is, from minus t by 2 to 0, it is anyway 0. I just have to integrate this from 0 to t by 2 x of t dt, right? As t tends to infinity, so x of t square, right? So as t tends to infinity, you can see, if this capital T by 2 is greater than 1, right? So, or if you generalize this, if you think this is t by 2, how many ones or how many boxes will be there before t by 2? So if t is 5, so here t is 7 actually. Right, so this is 7 by 2, which is 3.5. T, capital T is 7. We can see two boxes. Right? If capital T is uh, let's say 4.5, which is right. So what? So I'm just writing this x of t. Okay. Uh, just a second. Why am I getting confused here? Okay. Can you all try this? So if I say if I take some t by 2, how many rectangles will be there?
Sir,
Hmm.
I think answer should be B.
No, no, answer.
0.5 should be the power, no? The average power.
Why? Why is that?
The function has one value for 0 to 1,
Hmm.
and the same thing happens with 2 and 3, then 4, like every interval.
Correct.
So, like taking an average of a periodic signal can be equated to one signal's power.
No, right. So this is not a periodic signal, no?
Okay, but
On the
we are ignoring the this negative part.
you are ignoring the negative part. Uh we cannot do in that way, no? How can we ignore something? No, just a second. Let me just give me a minute, okay? Let me think. Hang on. Hmm. Okay. Instead of thinking how many pulses will be there within t by 2 interval, we can think in the other way around. So if let's say two pulses, we consider two pulses. Okay. So the time elapsed would be 3 seconds, right? So or we consider 4 seconds. So for 4 seconds, there will be 2 rectangular pulses. So like that, 6 seconds, we will have 3 rectangular pulses. So if we have n pulses, the time would have been 2n, right? So within n pulses, the time would be 2n, right? So we can think of it like that. And then power will be limit n tends to infinite. Now t is 2n, 0 to n by 2, right? And then, so within this n pulses, each pulse will have 1. So we have n pulses, sorry, n by 2. Till n by 2, we'll have n by 2 pulses. This will just give us n tends to infinite 1 by 2n into n by 2. Is this clear? Or if you want to take 2t and minus t plus t, that would be clear, I guess. So 1 by 2t, you integrate from minus t to plus t, then you will see, so 0, it is equivalent to integrating from 0 to t. 1 by 2t is basically 4n. Right. Okay, let's keep it 2t here. So this will become 4n. And from 0 to t, so from 0 to 2n pulses, right? 2n pulses, sorry, 2n, 0 to 2n or 0 to t, we will have n pulses, each of strength 1. So 1 plus 1 plus 1 plus 1, we will have this n rectangles. So you just have to add them together, which will give us n. Right? So therefore, you will have n by 4n, and n will get cancelled out, and we will have 1 by 4. Okay. So we can't use, the idea is we can't use average energy in one time period, because there is no time period for this. So you cannot, there doesn't exist any capital T such that if I shift with that amount, I'll get back the same signal. So this is a aperiodic signal, and you cannot use the idea of computing average energy in one period, one period length, and call it as the power of the signal. Right? So that cannot be done, and this is how we should do. So we have to use the formula that we know for the power, and then write down how many rectangular pulses will be there within this time interval. Okay, so if you do that, you will get option A, not B. All right. Yeah. So once you know that that is an energy signal, option C and option D are anyway not possible. So you just have to be within A and B, and you can see within one side itself we have half we have signal in half of the time, and we'll have 0 in other time, and the other side is anyway 0. So this side is 0, only half of the side you have half of the signal, so it's like half into half, 1 by 4. So that way also you can see that it is 1 by 4, right? So you'll get 0.25. Okay, so from here I think these are all pretty straightforward. So once you know the period of the signal x of t, then x of 3t's period, x of 0.5 t minus 1 period also we know. And once we are adding these two signals, you have to take the LCM, right? So period for this will be 5 by 3. Period for this will be 10. Correct? So if you take the LCM between these two, you'll get 10. Alright? And this is very straightforward. All you have to do is use the formula and you'll get 8. And this also, x of t is the signal like this, and then you just have to find this. So it's just sampling values, two sample values, right? And you can get the answer. It is -1. But be careful. It's not x. This is x of t. You have to shift your signal by 1 unit to the left. Right? Once you shift that, you will see that. Right? You guys can solve this. No, you will have this red signal as x of t plus 1. Now you just have to sample at t is equals to 0, and then t is equals to 3, it is anyway 0. So you'll have at t is equals to 0, you'll have strength of 1. So the integral will turn out to be equals to 1. And yeah, this one, you just have to be very, very, very careful. We have done a lot of problems related to this. There is a scaling factor, right? First you have to remove that scaling factor out. X cube delta x minus b by 2 dx. This is 32. Right? So now whatever inside the Dirac, that should be equals to 0. So that at that point we'll have the sample. So half into b by 2 whole cube is equals to 32. Right? So from here you'll see that b will be 8. Right? And yeah, so 10 to 14 is like just shifting, scaling and all. I think you should all do this. And the first three problems are very straightforward. The last two problems involve little bit of understanding. So once you sketch this, you have to describe that y of t in terms of rect. Right? So you'll have a rectangular signal. All you have to do is you have to identify the left point and right point, and then see what will be the representation of that y of t. Okay, so that is also okay. And this is like once you sketch this, after sketching this, what you have to do is you have to find this integral. Right, so these are fairly straightforward. And yeah, this is also okay, no? So what we did, this is x of t and this is y of t. We said the y of t and x of t are just shifted scaled versions of each other. And we asked you to give you the shifting and the scaling part. Right, so this y of t is x of 1 by a into t plus b by a. Right, so this is the scaling factor and this is the shifting factor. And you can clearly see there is a reversal happening and scaling also happening, shifting also happen. Right, so right, you shift this signal by 2 units to the left. If you shift it, you will have this, and then scale the signal by 2 units and then reverse it. Right, so we will have scale the signal by 0.5, so you have to stretch it, no? So we'll have y of t to be x of minus 0.5 t plus 2. Right, so then this is x of minus t by 2 plus 2, but that is not what we asked. Right, so this is x of t by minus 2 plus 2. So this is x of t minus 4 by minus 2. Right, so that's, you just have to compare it. This is b and this is a. Okay, so overall there are one or two questions, as I said, which consumes some time and our energy, but there are many easy questions that you can do and at least get some 60-70 marks easily out of 100. Right, so 60 is possible, but if you got confused or if you are unable to get 60 or 70, you should really work hard, because quiz 2 is going to be slightly difficult than quiz 1, and end term will be moderately uh, or average of quiz 1 and quiz 2. So quiz 1 is the easiest paper that you can score more, but even if you hadn't scored enough marks, do not worry. From now on, at least spend more time to get very good marks. Okay. Okay. So with that, I think I'm closing this discussion on quiz 1. If you still have any doubts, you can post in the chat or even in the G spaces or discourse, wherever. If you felt any question is ambiguous or any answer is incorrect, you can get back to us. But the deadline for it is tomorrow. So within these 2 days, you should get back to us. Okay, because the scores will be finalized and we will publish the scores by Wednesday. Okay. All right. Okay, so let's start week 6 then. So in week 6, we deal mostly on the characterization of LTI systems. Right. So what is the response of an LTI system given any input to me? And we can characterize the whole LTI system just by looking at the impulse response. So if I know what will be the response to the impulse input to the LTI system, then I can characterize the LTI, the system completely. So you give me any input, I can give you the output. So that is what the LTI system we got introduced to this LTI system in week 5 at the end, right? So all we need is the output, only the output per the impulse, which is called the impulse response h of t. Right? So only that need to be known. So once I know that, using this shifting property, I can write the output for any input x of t. Right? So all I use is this linearity and time invariant properties together. And if I know this h of t, just by computing this integral, right? So integral x tau into h t minus tau d tau, that will be our output y of t. Right, so we will closely, in week 6, we will closely look into what this integral is called and how do we compute this integral explicitly. Okay, so this integral is nothing but called as convolution integral. right? And it is denoted like star. So this is the denotation. So when we say x of t star h of t, this is what we mean. Integral. And the limits are from minus infinite to plus infinite, and the limits are for this variable tau, not for t. Okay. And how do we compute this integral, or how do we convolve x of t and h of t? Firstly, we have the impulse response is given to us. Okay, so remember that h of t will be given to us. Okay, so we will give you the impulse response, and we'll say this is the LTI system. This is the impulse response h of t. And then given any input to us, all we have to do is to convolve impulse response and the input. Right, so x of t and h of t we have to convolve. How to convolve them? Once we have h of t, we compute h of minus tau, right? So you just have to change the variable and do the time reversal. Once you do the time reversal, then for each t, you do the shifting. So if t is equals to 2, if t is equals to 2, then it is like you have to do the shifting by 2 units. Okay. So here shifting is like if you are doing reversal first, then in order to get h of t minus tau, you have to do the right shift by t units. Okay. So then do the shifting, then we'll get h of t minus tau. And then you multiply this h of t minus tau with x tau. And you will get a nice expression in terms of t and tau. Then you have to do the integral. That's it. Okay. So I will show you the animation also, but let us solve one simple example. Okay. So let's say this is the impulse response to an LTI system. Okay. So this is h of t for us. Okay. And the output, what we want is the output for the input u of t. So x of t is u of t. U of t we all know this is 1 when t greater than or equals to 0. It is 0 when t less than 0. Right. So the first step is to do the reversal. Right. H minus tau is e power minus, in place of t you have to do minus tau. Correct. Then step 2, you have to do the shifting by t units. Right. So t minus tau. So in place of minus tau you have to do t minus tau. Okay. So this is h of t minus tau. Then we also have x tau. So this is x tau, which is 1 when t greater than or equals to 0 and 0 when t less than 0. Right. So now we have to integrate. Step 3 is x tau into h t minus tau. So this will be 1 into e power minus of t minus tau u of t minus tau when tau is greater than or equals to 0, because you see x tau, this I can write it as tau. Right. So x tau is greater than x tau is 1 when tau is greater than or equals to 0. So when I multiply x tau with h of t minus tau, it will be 1 into h of t minus tau when tau is greater than or equals to 0. It will be 0 when tau is less than 0. Right, so finally if I compute x of t convolution with h of t, this is minus infinite to plus infinite, x tau h of t minus tau beta. So this will be integrated from 0 to infinity, because when tau is less than 0, x of tau is 0. So integral evaluates to 0. So from that we can ignore. The only left part is from 0 to infinite, x tau will be 1. H of t minus tau is e power minus of t minus tau into u of t minus tau d tau. Right, so now since the integral is for tau, we can pull out e power minus t out. So e power minus t goes out, and the integral is for 0 to infinite e power tau u of t minus tau d tau. So now observe again, u of t minus tau, this will be 1 if t minus tau is greater than or equals to 0, and this will be 0 when t minus tau is less than 0. So t minus tau greater than 0 is nothing but tau being less than or equals to t. This is tau being greater than t. So this is what we need. So when tau is less than or equals to t, only then this u of t minus tau will be 1, or else it will be 0. So therefore again the integral limits will change from 0 to infinity to 0 to t. So you just have to integrate it till t, because only till then u of t minus tau will be 1. So this will be u tau e power tau into 1 d tau, plus there will be t to infinity e power tau into 0. So that will again be 0. Okay. And you can clearly see that when I am writing
Sir, please
this,
explain again this limit.
this limit,
Yeah.
how it came to 0 to t, is it?
Yes, sir.
Okay. So we are trying to integrate this particular expression. Right. So this particular expression, we have u of t minus tau. So we know that is a step function. And that is, so if I plot this u of t minus tau, right? So u tau I have u of tau is this, right? So then u of t minus tau will be like you have to reverse it and then shift by t units, right? So if you do those things, so this is u of t minus tau, and this is tau t. This is exactly a t. So t is a constant, tau is a variable, t is a constant. Okay.
Okay, now I understand. Here T, we have to consider T is as constant.
T is constant.
Okay.
So u of t minus tau will just be 1 only till t, right? So above t, this u of t minus tau is 0. So integral of 0 will give me 0. So I don't have to integrate from t to infinite. I just have to integrate it from 0 to t. Okay. And
Understood.
yeah, so this t should be greater than 0. If t is less than 0, again, if t is less than 0, the whole integral will become 0. Right? So this is when t greater than 0. And when t less than 0, this whole integral will become 0. So now all I have is e power minus t, 0 to t, e tau, e power tau, d tau when t greater than 0. Right, so I know how to integrate this. This is e power tau and the limits are t and 0, e power minus t, e power t minus e power 0 is 1. Okay, and this is 1 minus e power minus t when t greater than 0 and t less than 0, this will be 0. And this is our output. This is our output y of t. Right, so our output y of t is like this, and I can combine this by using u of t. So I can write this as 1 minus e power minus t into u of t. Right, so that u of t will take care of t greater than 0, t less than 0 thing. So this will be the response to u of t, where my impulse response is given to be e power minus t u of t. Okay, so this is the impulse response for the LTI system. Given that the impulse response is this, now we found the output for the input u of t. And this is called, actually this is called the step response. Right, so when I give the step function, which is u of t to the system, what will be the output? The output is called as step response. This also you'll see in the later lectures. But for any x of t, we can find y of t by using this convolution integral. Okay. So how exactly this convolution is happening is, let me show you the animation part. I think in the lectures also professor has shown this clearly. You can also watch that. But let me show from my end. Okay, I think my new screen is visible, no? Okay, so is my screen is visible? The other screen, like there is some rectangle floating
Yes.
around and yeah. So you can see on the right top, this is f tau, which is our signal x of tau. Okay, so this blue one is the x of tau. It is like e power minus t u of t. Okay, so think of it like e power minus t u of t. And this is our rectangular signal. Okay, what we did is we did this g of t minus tau. So we already computed, and this rectangle is the g of after step 1 and step 2. Okay, you flip, then shift, then you have this. Now what you have to do is you have to run this over the signal that we have. So till here, we will not have any intersection. The product will become 0. So the integral will also be 0. After this point, you will have some common region, right? So the product between these two and the area under this region is what we want. Right, so the area under this region, you can see this dotted line will float now. So the area under this region is plotted by this curve. right? So the area increases till this point, right? Then after this point, you see you will start losing, this area now, right? So the area will decrease and it will just decrease. And as you move towards right, the area will further decrease. And this dotted black thing is the convolution graph. Okay. So you can also see this, visualize it better with two rect signals. Okay. So when you convolve to rectangular signals, rectangular pulses, you will get a triangle. Okay. So you all can try it out. You'll see that this is what convolution means. So you keep one signal fixed, you take the other signal and you reverse that signal and shift that signal by some units, right? Or you reverse that signal and then run that signal from the leftmost corner to the rightmost corner. So those are the limits for tau. So tau going from minus infinite to plus infinite, right? So when you do that, that black dotted line is the convolution curve. So that is what f star g t. Okay. I hope this gives you some sense. But I strongly recommend you guys watch the lectures of week 6, week 5 last lectures, and week 6. And week 6, we talk about some properties of this convolution, like commutative. So even if I do x star h or h star x, both are same. Okay, so we'll get the same integral. And then associativity, distributivity, all these laws or properties of convolution we'll see. And then we'll see finally we'll end week 6 by looking at step response. So what happens or what will be the response when I give u of t as my input? Okay, so those also we'll see. All right, so those things we'll see on Wednesday. It's an 2 hours session. Okay, so we'll cover a lot of things there. And if you have any doubts in week 6 also, we can discuss at that point. Right? So that's about the introduction to convolution. Solve more and more problems on convolution. I think when you sit and solve, no, only then you will start seeing the difficulty in convolution topic. Okay, and it is very, very important. Convolution between a signal and impulse delta, or convolution between rectangle and a rectangle, convolution between rectangle and u of t. Okay, so some standard signals, take some standard signals and do this convolution. So e power minus t convolved with u of t. So just now we saw it. E power minus t convolved with rect t. So all these things are very, very important. Okay. All right then. We'll meet on Wednesday. Thanks all and have a great day. Bye.